Imagine driving along a road perched at nearly twice the height of the Eiffel Tower, so high that you literally pass through the clouds. That is the experience on China's Huajiang Bridge, a structure inaugurated in September 2025 that quickly became a new icon after setting the record as the highest bridge in the world, with the bridge deck positioned at an elevation of 2,050 feet, equivalent to 625 meters above the water. Not stopping at its record-breaking height, the Huajiang Bridge challenges engineers by stretching across one of the most treacherous gorges in western China, where harsh terrain and dense layers of fog have forced many previous projects to be abandoned long before construction. But what makes the Huajiang Bridge even more remarkable is that right on top of its tower, they built a glowing cafe in the clouds, something that sounds like science fiction, yet is completely real. In this video, join Mandarin Tech as we explore how Chinese engineers turn this bold project into reality. The journey of this record-breaking bridge actually began in one of the most rugged regions in all of China. Guizhou Province is known for its harsh terrain. More than 92% of its area consists of high mountains and plateaus, and between them lie 8 major rivers and countless tributaries that form deep valleys, making transportation and trade a constant challenge. Therefore, to build the Liuji-Anlong Expressway, connecting Liupanshui with Anlong County, the route was forced to pass through the dangerous junction of the Beipan River within the Huajiang Gorge. And that is why the Huajiang Bridge was created, a structure whose significance goes far beyond that of an ordinary bridge. During the survey phase, engineers faced 2 options with similar costs. One was to build a gentler approach road, but place the bridge near the mountain peak. The second option was to build the bridge lower, but run it across a series of steep slopes and long tunnels. In the end, they chose the challenge of approximately 2,050 feet. However, the V-shaped gorge created a distance of more than 4,593 feet, equivalent to more than 1,400 meters between the 2 cliff edges. At this scale, every other bridge type failed. The tallest rigid frame girder bridge in the world could not span the distance, the longest arch bridge could not reach it, and even the largest cable-stayed bridge did not have the capacity to cross the span. Only a suspension bridge with an ultra-long main span could meet these extremely demanding engineering requirements. So how do you build a massive bridge in such unforgiving terrain? In principle, there are 3 steps. Start by constructing the 2 towers, then pull the 2 main cables into place and anchor them securely, and finally hang the bridge deck using the suspension cables. But that is only the theory. In reality, everything is far more complex. The Huajiang Bridge stands 625 meters above the river, spanning 1,420 meters across the canyon. When including its tower structures, the bridge stands comparable in height to the tallest man-made building in the world. With figures this enormous, it's clear that the Huajiang Bridge is not only massive on paper, it demands a construction process far beyond the standards of ordinary infrastructure projects. Aside from the challenges posed by the terrain, the foundation of the structure presented another difficult problem. The foundation of the bridge tower had to be drilled deep into weathered rock layers filled with cracks and groundwater, where even the smallest error could lead to serious accidents. Therefore, the engineers used a special piling system by driving 24 massive concrete piles deep into the ground, combined with anti-seismic steel reinforcement, to ensure that the tower could withstand decades of operation. After overcoming the challenges of the foundation, the next step was to erect the 2 backbone columns of the entire bridge. The 2 main towers, one 262 meters tall and the other 205 meters tall, serve as the anchoring points for the entire load-bearing cable system. They were constructed directly on the mountainside, hundreds of meters above the gorge. Along with the 2 massive cables weighing more than 9,000 tons each, these towers support the bridge like 2 giant pillars holding a ribbon in midair. Stability is critical, so the entire structure is reinforced with high-strength steel, capable of withstanding strong winds, vibrations, and even earthquakes throughout its design lifespan. However, for those massive towers to truly exert their strength, the cable anchor system at both ends of the bridge must be strong enough to hold the entire structure in place. The anchors of the Huajiang Bridge function like giant counterweights, locking the two main cables firmly into the mountains. On the Zhenfeng side, the gravity-type anchor sits solidly on the mountainside, with a total concrete volume of up to 164,000 cubic meters, forming an extremely stable resistance block. Meanwhile, the anchor on the Guanling side was designed as an anchor tunnel. Instead of placing a massive concrete block on the surface, the engineers carved deep into the mountainside and attached the anchoring system directly to the natural rock to transfer the full tension of the cables into the mountain itself. The reason for this choice is clear. Behind the tower on the Guanling side is a steep mountain, but the amount of flat land available behind it is extremely limited. Therefore, using the mountain itself as a natural anchor became the optimal solution, saving space while increasing the stability of the entire structural system. After completing the anchor blocks, the next step was to install the catwalk, a temporary walkway suspended between the two towers, where workers would construct the entire cable system. To pull the first pilot line across the gorge, which is thousands of feet deep, engineers used drones, making the wire guiding process safer and more precise. Once the pilot line was successfully pulled across, the catwalk was formed, creating the foundation for the most critical phase, constructing the bridge's two massive main cables. The next step, and also the most important stage of the entire project, was the construction of the two main cables, the load-bearing backbone of the whole bridge. Each main cable consists of tens of thousands of high-strength steel wires twisted together with absolute precision to form a structure capable of carrying tens of thousands of tons of load. On the catwalk suspended in midair, workers installed each cable strand, with every strand made up of 91 high-strength steel wires measuring 5.7 millimeters in diameter, pulled back and forth between the two anchor points under GPS supervision to maintain an error of less than 2 millimeters. In conditions of high winds and an elevation of thousands of feet, controlling every movement of each strand was critically important. Once all 217 strands were installed, a cable compacting machine compressed and bound them into a circular cable using a specialized compaction process, after which the cable was wrapped in multiple protective layers to resist corrosion, weather, and vibration for decades. Only when these two massive main cables were completed could the bridge truly move on to the next stage, suspending the bridge deck in midair. Once the two main cables were completed, the bridge moved into its decisive stage, suspending the bridge deck. First, the engineers installed the system of vertical suspenders, each one attached to the main cable using specialized clamps capable of withstanding thousands of tons of force. These suspenders transfer the load from the bridge deck to the main cables and then distribute it to the two anchorage points. Next, the entire bridge girder, consisting of 93 steel segments, was lifted one by one from the center of the bridge and gradually extended outward toward both sides. Each segment, weighing hundreds of tons, was hoisted using a pulley system suspended more than 2,000 feet above the water and connected to the suspenders through specialized load-bearing joints. During installation, the engineers had to constantly adjust the cable sag, the tension in the suspenders, and the position of each panel to ensure that the entire deck remained aligned without tilting or twisting under wind forces. Once all 93 segments were in place and connected into a unified structure, the deck system was then constructed on top, transforming the suspended steel framework into a fully functional expressway. After construction was completed, the next step was to assess the bridge's actual strength. In the load test conducted in August 2025, 96 heavy trucks with a total weight of 3,700 tons were used to evaluate the bridge's load-bearing capacity and dynamic performance. More than 400 sensors recorded data on deformation, stress, and vibration, ensuring that the bridge met the strictest safety standards. This test not only confirmed its absolute safety, but also demonstrated breakthroughs in real-time structural health monitoring. Throughout the construction of the highest bridge in the world, The construction team constantly faced extremely harsh challenges from both nature and the terrain. The Huajiang Gorge is known for its strong winds. During favorable seasons, wind speeds can reach level 14 on the Beaufort scale, while construction must be halted whenever winds reach level 6 or above to ensure worker safety. When transporting steel girders to the installation position, the stabilizing ropes would sometimes become tangled, forcing workers to manually straighten them and keep the lines balanced between the upstream and downstream sides to minimize the risk of twisting. They began working at 6 a.m. and often did not return until after dark. Beyond the wind and the rugged landscape, the sheer volume of construction materials also posed a major challenge. The Huajiang Bridge required a total of 439,000 cubic meters of concrete, equivalent to 176 Olympic-sized swimming pools. To reduce costs and protect the environment, the engineers reused waste rock produced during construction, crushing it into high-performance green mineral powder, and using it as a supplementary material to replace 20% of the cement in every cubic meter of concrete. This approach not only saved cement and reduced costs, but also made full use of waste rock, helping limit pollution and conserve natural resources. Thanks to these measures, the construction team not only overcame the natural and geographical challenges, but also delivered the project in a sustainable and efficient manner. After all the effort spent conquering mountains and cliffs, the bridge now opens up an entirely new world for this region. In the past, traveling from the bridge area to Guiyang City took at least 3 hours. Now it takes no more than 1.5 hours, saving nearly half the time. Faster travel not only makes life more convenient for local residents, but also benefits thousands of others across the area. As a transportation project combined with tourism, the Huajiang Bridge was designed from the planning stage to ensure both structural integrity and visitor experience. With wide views, ideal elevation, and beautiful scenery, both sides of the bridge were equipped with safety rails and a specialized pavement coating that not only stabilizes the deck, but also supports high-altitude adventure sports. Inside the steel girder is a visitor walkway that, if not built for tourism, would simply serve as a maintenance passage, and its impact extends far beyond what is visible. By connecting to the G56 expressway, the bridge not only shortens travel time, but also opens up regional trade routes between China and Southeast Asia, attracting investment, creating jobs, and improving education, healthcare, and tourism, bringing the entire region closer to a prosperous future. The Huajiang Bridge is not only a massive engineering structure, but also the culmination of the intelligence, effort, and perseverance of Chinese engineers. From the very first days of drilling deep into the rock layer, pouring concrete for the main tower shafts, to completing the tower tops, installing the transverse steel girders, tensioning the suspension cables, and fitting every locking component. Each step was filled with challenges and demanded absolute precision. Looking back at the entire process, the bridge seemed to grow day by day, from when it was merely an idea on paper to when it finally became a majestic reality spanning the deep canyon. The story of the Huajiang Bridge is not only the story of a world record, but also a testament to the transformation of Guizhou province, from a remote and rugged land to one that is now integrated into the modern rhythm of the 21st century. Stay with Mandarin Tech as we continue exploring more mechanical marvels and extraordinary technological breakthroughs across the planet, where human imagination and perseverance bring to life things once thought impossible.